All right, here's a question where you're asked to find the domain of this function. To find the domain, you want to find all values of x that are legitimate. And basically, you're looking for ones that aren't legitimate, and then you say the domain is everything else. So this one, you're right to factor it. So the first one would be x plus 3, x minus 1. And then on the bottom, this is a difference of squares. So that would be x minus 3, x plus 3. Okay, now, even though this is a square and this is a square, if it's a difference, then you factor it this way. You can't just sort of take the square root of each one. I guess you're sort of doing that, but because it's a quadratic, there have to be two factors for it. And so it's x minus 3, x plus 3. Now, since I have a similar factor on the top and the bottom, I can remove that factor of 1. And so my expression changes to x minus 1 over x minus 3. So now I can zero in on this and say, well, what values of x can I not use? Well, no, domain is what values of x can I use. And I focus on what values I can't use, and then say domain is everything else. So here, hopefully you can see that if you put a 3 in there, 3 take away 3 is 0, and you can't have a 0 on the bottom of a fraction. So 3 is a number you can't use. So you would say your domain is all the x's as long as x is not equal to a positive 3. If you want to do it in interval notation, so here's 3 there, so it can't be this number. So it can be everything here up into that number, and then from that number beyond, and you would just state those two intervals. So from negative infinity all the way up to 3, not including 3, union with everything from 3, not including 3, and to infinity. Okay, hopefully that helps with that domain question.